Welcome, welcome, welcome. I'm Lisa Blackburn, and this is my YouTube channel where I talk about science and math. And what we're doing today is we are going to go over the study guide for Unit 1 that is really about the math of chemistry. So it's in this playlist. If you didn't get the notes, go back. There's 3 videos for the notes. All right, so what I wanted to do was I wanted to go over the study guide, and that way you could check your answers and it would help review you. So if we had been in class this week, there's a couple of things. One, I would have passed around the element report thing, and you would have signed up for your elements right then, instead of me having to something that normally takes 3 minutes in class, because we were digital this week, took days of me emailing people back and forth. And some of you still have not let me know what your element's going to be for your element report. How you let me know is you go to Canvas. You go over to the left-hand side, there's an inbox. And you should have gotten an email from me saying you need to sign up for an element report now. And you need to let me know which one you're going to do, because you're going to become the resident expert on that element. And for the rest of the semester, if you signed up for gold and I want some fact about gold, I'm going to turn to you and you're going to tell me that information. So the other thing is, and I didn't really make all of this clear because normally I just say this in class, but we weren't in class, is for your element report, how you turn this in and what you're going to do is you're going to present your information to the class. You're the resident expert, and you're going to need to have your poster, your graphic thing with your pictures on it, your element card that you're going to show, and then you're going to give your oral report on your element, and it needs to take like 3 to 5 minutes. Don't go longer than that. But it is more than a 30-second, I had gold, it's yellow and shiny, it conducts heat and electricity. Da-da! Buy gold, it's great. That will not get you a good grade. You're looking, this is a test grade, and I want a test grade worth of work on it. Remember how I said be creative? This is an advertisement, and you will not get 100 unless you throw in the creativity. So I've had people do all kinds of things in the past. I've had people sing songs, do dances, do skits. Last semester, I think I had the best one I've ever had. I had a student who he became the professor who discovered it, and he taught it like we were his class at the university where he taught. So he explained how he discovered it, the properties, all of these things as the professor who discovered it. And so that's how he presented his information. He didn't have to have a poster because it didn't really go with the way he presented it. So you may have some creativity, you may have some leniency, you can have some differentiation in how you accomplish this task. You can have some choice in the matter. Now you can do it just straight the way it's written, or you can get more points for being more creative with it than as it's written. You don't have to, you can talk to me about it. The kid who said, I don't want to do a poster because I'm going to teach this element as the professor, he got that approved by me first, and I was like, fine, sounds great. Also, he did the whole thing in a British accent because the guy was British. I was very impressed. It was the best because he really knew it because he was able to teach it. There's this thing called Bloom's taxonomy of objectives for teachers that shows higher order thinking skills, and he definitely demonstrated some higher order thinking skills by the way he did his element report. So I've done this assignment for decades, so you're up against some competition. I've seen some good ones, so I've also seen some okay ones. So you just gotta check all the boxes to pass. To get up from passing, you got to do a little more than that. All right, so next we're going to talk about the study guide, because next week we're back face to face, and you've got a lot of test grades coming up. I try to give you a lot of good grades at the beginning, so later when it gets harder, you can bomb a few tests and still be okay with your grade. So your good grades were your lab safety test, and y'all did do good on that. I'll be passing those back. Your element report, that is usually a pretty good grade. your element test, where you have to know all the elements, and then this is your first other test, your real test. All those others are test grades, but this is your real test, which is the math of chemistry, which is a math review that a lot of you have already learned this in math class, so it shouldn't be too bad. But if you don't know how to do it, make sure you know how. This should be one of your easy tests, even though it's a math test. So make sure that this is a good grade. All right, so get out your study guide and we'll go over it together. Got yours? Now, let me say also, it is a totally different skill set for you to watch me do the problem and understand it and write the answer down than for you to be able to do it. So if you have not done your study guide yet, turn this off, go do it, and come back and then check your answers. Because I don't want to just give you all the answers. You won't be learning how to do it by yourself. Also, the test is going to be similar to this, but it's going to be more than this. It's going to have more comprehension questions like, how many kilograms do you think a baby is? I want you to have that estimating metric in our metric Olympics labs that we did. That's supposed to help you think metric. You should know that a millimeter is about as close as you can get your fingers together. A centimeter is about as big as your pinky nail. A meter is about as big as your wingspan, how far you can hold your arms out. You should be able to start thinking metric. And so there's going to be some of those thinking metric questions on there. All right. So number 1 on our study guide, it says give the number of significant figures in 6.0400 70700.00088 7008. So let's just do all of those together. I use broken phones for YouTube, so I was going, what is that on the board? It's the cracked screen. Anyway, back on task. Okay, so remember, the whole thing about significant figures is we want to be honest scientists and not present our data, our results as more well measured than they were. We don't want it to look like we use the analytical balance when we use those cheap little balances that half of them are broken in our room. Okay, we want to make it look like our data reflects the science that we did. So you have to follow rules called significant figures, but of course the cool kids call them sig figs or sig digs, right? All right, so this one, it's got the decimal point right here. The numbers that are not 0 are always significant. So the real question is, are these zeros significant? And the answer is yes, because they come after a decimal point. Zeros after a decimal point count, 1, 2, 3, 4, 5. That one had 5 significant figures. This one has no decimal point. Zeros at the end with no decimal point don't count. Zeros in the middle of 2 non-zero digits count. So this one has 3. This one, it has a bunch of zeros at the beginning after a decimal point. Zeros at the beginning after a decimal point don't count. They're considered placeholders. So this one only has 2, the 88 at the end. This one, the zeros are in the middle. Zeros in the middle of non-zero digits count. So that one has 4. All right, so it should have been 5, 3, 2, 4. Okay, next. Hopefully, if we were at class, I'd say, do y'all understand? So I always, when I'm teaching to the camera, I always wanted to ask the camera, do you understand? And it never answers back. I'm going to assume you do. Email me if you don't, through Canvas. You can text me. Okay. Complete the following using the rules for significant figures. So we have 95.864 minus 17.99. Now, the rules are, if you're adding and subtracting, you look and see how many decimal places you have, and whatever the least is, that's what you round your answer to. When you do your math, you use all the significant figures. So when I put this into my calculator and did the math, I got 77.874. And that would be milliliters. You always want to put units because a number without units is meaningless in chemistry. Okay, so this one has 3 decimal places, And this one has 2 decimal places, which is less, 2. And I've got 3 in my answer, so I need to round it to 2 decimal places. 4s leave the digit alone. 5 and up round up. So the answer is 77.87 milliliters. Is that what you got? Okay, let's do the next one. Complete the following using the rules for significant figures. I'm going to normally in class I'd be like, can I erase it now? I'm erasing because y'all can always pause the video, remember. Okay, complete the following using significant figures. It's 66 grams divided by, I get my old lady glasses here, 45.76 centimeters. Okay, remember we put all the numbers in our calculator. Oh, and also remember, you cannot use your phone on the test. You've got to have your calculator. So, little warning, I'm going to have calculator quiz where everybody's got to get out your calculator and do some little quiz. And if you don't have a calculator, you're going to make a 0 on it. So I'm more motivated to get you to get your calculator early in the semester. Last semester we had so much going on with COVID and stuff. I was a little nicer than usual and let the kids dilly-dally about getting their calculators. Not this time. This time, I think you've had a whole week off this week for home learning, digital learning. You could have hopped out to the store and gotten yourself. You don't have to have one as nice as mine. I recommend you get one as nice as mine. If you can get a TI-84, get it. And remember I told you, use your mom. Get your mom to go on Facebook and say, does anybody have a TI-84 or 3 or 2 calculator that I can buy? Get her to offer her friends $20, and usually the friends will just give it to them. I promise you, half my students through the years have gotten their TI-84s that way, because everybody has to have them for college. They go to college, they don't major in science or math, and they throw them in a drawer, and then they just sit there gathering dust. So, all right, so we're going to do this on our calculator, and then the answer we get is 1.442307, etc. Now, you put all the numbers in till you do the math, and then you figure out if it's multiplying and dividing, how many significant figures does this number have? Well, it has 2. And how many does that one have? It has 4. So this time, instead of looking at the number of decimal places, because it's multiplying or dividing, we count the number of significant figures, and whatever is less, that's what we have to round our number to. So we don't look at any of the rest of the number, we just look at the 2 significant figures and what's next to it to see if it's going to round it up or down. 4 leaves it alone, so the answer is 1.4 grams per centimeter. Dun, dun, dun. Did you get it? All right. We're doing great. Zipping through this review. Okay, number 7. A cylinder has a diameter. Now this one's a really fancy little math. Do you remember your geometry problems? Do you remember your geometry formulas? And I know probably some of you are in geometry now. And you might not have gotten to this yet, but that's okay. I always learned my math in science before I learned it in math. So hopefully you'll be okay with this. So it's a cylinder. So I'm going to draw a cylinder. When I teach geometry, I tell the kids always draw the picture. It helps, okay? So a cylinder. Remember what I said? What makes word problems hard? The words. That's right. So what we want to do is get rid of the words and just have pictures and numbers, because the numbers are easy. You put them in your calculator. So easy. All right. So I have a cylinder. Check. Got rid of those words. That has a diameter of 6 centimeters. So I'm going to draw my line going across and write 6. That's my diameter. Okay. And a length of 10.7 centimeters. Okay, so that's my next thing. It has a mass. Now, when I do math, I write the knowns and unknowns over here. So I'm going to list this. Diameter equals, I'll put DIA. Usually big D is diameter in geometry, but we use big D for density in chemistry, so I'll write DIA. Diameter is 6 centimeters. And my length, and by tradition, length is written in cursive. See, that's why you had to learn cursive in 3rd grade. I know some of y'all don't know cursive because they don't stress it the way they used to. But I've heard it's coming back. It's like new math, old math. all the things that they do, and then they get rid of it, and then they bring it back. All right, so we have the length, and we have the diameter, and now we were told that the mass is 45 grams. 45 grams, and the question is, what is the density? So I'm going to write density, since I got another thing with D, and I put a question mark. So that's what I mean by listing your knowns and unknowns. Put it over to the side, write what you know, write a question mark for what you don't know. And then you think, is there a formula? I got a low battery warning. If this cuts off, we'll have to have part 1 and part 2. I'm getting rid of the low battery. That's why I'm touching this. I'm touching your computer. Choo, choo, choo. All right, focus. Okay, so what is the density? So what I think now is, there any formulas that really relates this? And density equals mass over volume. So mass, check. Density, check. Volume, not check. So then I think, well, what's the formula for volume? Volume of a cylinder is the area of the circle times the height, or we'll call it the length here. I usually call it the height when it's a cylinder, but we'll call it the length. And, okay, so good, we've got the length, but we don't have the area. So I need another, I have a cat who is about to bother us here. She wants out. Get down, cat. All right. Anyway, so we need the formula for area, and area equals pi r squared. Cornbread all around, pi r squared. You have to use the science jokes and the math jokes when you know them. But that still doesn't happen because I don't have radius, but I do know that diameter is equal to 2 times radius. Woo! I told you that this was going to use a lot of our math skills. Okay, so now we can work our way back up and do the math. So once you write the formula, you sing a song. Do you remember the song? Substitute is by The Who, before my time and yours, but we still sing it, because right underneath we substitute. So our diameter is equal to 2 times the radius. Wait, we're going to do it the right way. So 6 is equal to 2 times the radius. So what I want you to do is I know you can do this in your head, but we want to get in the habit of doing our math correctly. So I substitute by writing the number that I can fill in right underneath its symbol. And now I'm going to solve for r. How do you solve for r in algebra? You do it by doing the opposite, meaning whatever's happening to it, you do the opposite. And you're allowed to do it as long as you do it to both sides of the equal sign. So radius is being multiplied by 2. What's the opposite? Divide by 2. What I do to one side, I do to the other. R's cancel out, and the radius equals 3. Okay, so now I've got another fact over here. Radius equals 3 centimeters. And I know you could have done that in your head, but we're just practicing doing our math properly. I'm shoving a cat. Did you hear it? Thump, thump. She really wants out. Here, I'm going to let her out. Out you go, cat. Okay, sorry about that. Cat interruption. Okay, so now we're to this. I can say area equals pi 3 squared, because I'm substituting into this. So area equals pi times 9. 3 times 3 is 9. And then pi times 9, pi is about 3.14. And let's see if I wrote down my area where I did it out. It should be around 28. There it is. So this is equal to 28.26. Okay, so now I've got area equals 28.26 centimeters cubed. When I cubed that 3, it was 3 centimeters cubed. So now my unit is centimeters cubed. So now I have area, and I can get rid of that. Okay, so now I'm up to volume. Volume equals the area, 28.26, times the length, which is 10.7. Okay, so our volume, where did I write my volume down? Is equal to 302.382. And this would be, oh, that was centimeters squared, not cubed. This is centimeters cubed. There we go. We only squared it. We didn't cube it. All right, so that's our volume. So now we have that. Volume equals 302.382 centimeters cubed. All right, so now we have our volume. I can get rid of that. And now we are ready to do our problem. Density equals mass over volume. Our mass is 45 grams, and our volume is 302 point, and you keep as many decimals as you can until you do the math, and then you round. We're dividing, so we got 0.1488183, etc. Now, looking at our numbers, what significant figure should we round this to? Now, we got, it's this. This 6 is only one significant figure. So we should round this to one significant figure. We don't look at that 8. We only look at the number next to the one we're rounding. It's a 4, so it's 0.1 grams per cubic centimeter is our density. Box your answer. All right, so that one was pretty long and complicated, but not really bad, right? It was pretty fun. Math is fun when it's hard. It's boring when it's always easy. I much prefer teaching Algebra 2 to Pre-Algebra. Pre-Algebra, you're teaching those kids the basics, and that's good because I feel like I'm giving them a good foundation. But Algebra 2 is where you get the fun problems. Okay, let's go on. So that one was number 7. Number 8. Would the cylinder in problem number 5 float or sink over water? Water has a density of 1. So 0.1 is less than 1, so it would float. If it has a less density, it floats. If it has a greater density, it sinks. Okay, next. Number 9, the volume of an object, so I list what I know. The volume equals 67 milliliters. Okay, the mass is 12 grams. This one looks pretty easy so far. What is its density? That's very easy. Okay, and then they want it in scientific notation. So I always write my formula, density equals mass over volume. Write your formula every time. It'll help you memorize your formulas. Then we sing substitute. And so this is 12 divided by 67. And it was 0.1791. Okay, and it said put it in scientific notation. And remember, scientific notation is you have your non-zero numbers times 10 to an exponent. Okay, so we need this 1 to hop into its proper place, that decimal to hop in its proper place behind the 1. So it's 1.791 times 10 to the negative 1 power, because it's hopped, it's a small number, it's less than 1, so it's a negative exponent. But then if we look at our sig figs, it should only be 2. So, so that means we're going to round to this place. 9 is going to round the 7 up to an 8, so it's 1.8 times 10 to the negative 1. Now, I teach physics also, and the physics book I teach out of does this all the time, where it takes a number that you can kind of imagine, 0.17. You realize that's only about a tenth. You can imagine a tenth of something, and they put it in scientific notation that we have a hard time understanding. It's hard for me to look at that and know, oh, that's about a tenth, or, you know, like that. So, or maybe, almost 2/10. My brain just doesn't work that way. So I don't like it when you put numbers that are easily represented not in scientific notation. They're not huge, they're not tiny. I like them to be not in scientific notation. But for this test, you just do whatever it says. Just know though, it's sort of a pet peeve of mine. With physics books, trying to put, in chemistry books, we'll put everything in scientific notation, and I'm like, oh please, you're just trying to look like you're smart. And you know, you can be smart without putting every single little number in scientific notation. The point of scientific notation is to write really big numbers, really small numbers, and to put numbers in your calculator that are bigger or smaller than will fit on your display screen. Not to just make numbers confusing. All right, so we did that one. That one was number 9. Let's do 10. The density of an object is 44 grams per milliliter. Okay. The mass is 8 grams. What is the volume? So we write down our knowns and unknowns, then we say, is there a formula? Yes, there is. Density equals the mass over volume. Now what do? We sing, substitute. So 44 equals 8 over volume. Do not rearrange it for volume, because otherwise you'll end up not memorizing your formulas. Now do the math. So when you do the math, what do you do if your unknown is in the denominator? What you always do, you do the opposite. 8 is being divided by volume, so we're going to do the opposite, and we're going to multiply by volume. What you do to one side, you do to the other. These volumes cancel out, and by tradition you usually write it like this. 44 volume equals 8. Now why is volume not alone? It's being multiplied by 44, so what's the opposite? Divide by 44. What you do to one side, you do to the other. These 44s cancel out, because whenever you have the same thing in the numerator and the denominator, you get to cancel it out, which is one of my favorite things about math. I know it doesn't make sense, but somehow I find it deeply satisfying to get to mark out math and cancel out. I just love it. It's like popping bubble wrap. It's really fun. All right, so now we put it in our calculator and we do the math. So this is the one we're doing. No, we already did that one. We're doing this one. So it is, the answer is equal to 0.1818, etc. But we look at our significant figures, and this has only got 1, so we need just one significant figure. So it's going to be 0.2, and this is a volume, and we can tell from here what our units is. It's 2 milliliters equals our volume. Dun-dun-dun! All right, feel good about that? Number 11, a rectangle has a length, okay? So when you're doing density problems and they tell you a rectangle, you know this is going to end up being our volume, but we're going to write it down. A rectangle has a length, remember I told you by tradition in cursive, it has a length of 8 centimeters. It has a width of 6 centimeters. Oh, is this number 11? Yeah. On yours, number 11 had a typo. It had 6 and a 3. It was only supposed to be the 6. If you use 63, more power to you. Good job. If not, that's all right. I'm going to go with 6. And a height of 14 centimeters. Okay, and it says it has a mass, and all of those are by tradition written in cursive. It has a mass of 550 grams. And the question is, what is its density? Okay, so we think, is there a formula that is for density? Yes. Density equals mass over volume. Don't have a volume. Is there a formula for volume? Yes. Volume equals length times width times height. By tradition, written in cursive. All right, so now what do? We sing, substitute, and we're going to substitute them in. Right underneath L, we write 8. Right underneath W, we write 6. And right underneath height, we write 14. We do the math on our calculator, and we get 762 centimeters cubed, because we did centimeters times centimeters times centimeters is centimeters cubed. That's a good volume unit. Now we can put it over here. Volume equals 762 centimeters cubed. And now we can do our density problem. Density equals mass over volume. Substitute. Mass is equal to 550 divided by 762. And that is 0.7217. If we look at this our lowest significant figures is 1, so we need to round it to 0.7. 2 doesn't affect 7, leaves it alone. So the answer is 0.7 grams per centimeters cubed equals our density. Dun-dun-dun, we did it. Okay, next one. Number 13. These are a little bit easier because, oops, I dropped my eraser on the floor. All right, next, we're going to convert, okay? Number 12. With the problem in the cylinder in 11 sink or floating water is less than 1. Oh, we're still on low battery. We're down to 10%. So it would float. I should have given you 1 to float, 1 to sink, but I was just doing it fast, making the study guide, so sorry about that. It would float also. Number 13. We're supposed to change 7.88 milligrams to kilograms, okay? Now, because these are both metric system, we can frog jump. We don't have to dimensional analysis. King Henry's daughter bakes delicious chocolate muffins. We're going from milli to killi, and we're going to count how many frog jumps it is. 1, 2, 3, 4, 5, 6 in this direction. So we go 1, 2, 3, 4, 5, 6 in that direction. We augment zeros for each hop, and it is, you can put a 0 first or not, 0.00000788 kilograms. Then, do they want it in scientific notation? No. All right, so let's do the next one. Oh, here's another one. You calculate that 7, 6, 8, 1, 2, 3, 4, 5, 6 meters is the answer to a problem. Write it in scientific notation. Okay, scientific notation, our frog, look, we'll make him look like a frog, has to jump to his proper place, and we count the jumps. 1, 2, 3, 4, 5, 6, 7, 8. So it's 7.68 times 10 to the 8th power. It's positive because it's a big number. If it's a little number, then it's negative. But this is a big number, so it's positive exponent there. All right, the next one is you calculate the following answer to the problem. 12.755, round it to 4 significant figures. So let me write that one down and we'll do it. Okay, this one is 12.755. It needs 4 significant figures. So the 5 rounds the 5 up to a 6 is 12.76. Dun, dun, dun. Okay, finish with page 1. Page 2. We got to convert things from, with King Henry's daughter bakes delicious chocolate muffins. Kind of put me in the mood for chocolate muffins. Our first one is 0.8465, and we're going from liters to milliliters. Our next one is, I'll leave some room. Okay, I scribbled on mine and I was like, where is there a decimal point? I shouldn't have scribbled all over my paper. 5378 millimeters to kilometers. And then we've got 8,000 milliliters to liters. And then we've got 835 meters to centimeters. All right, so we're going to go liters to milliliters. Liters is the basic unit, so that's 1, 2, 3. So my decimal point goes 1, 2, 3. The answer is 846.5 milliliters. Did you get it? Whoop. Liters to milliliters. I was like, I got the wrong answer. Okay. Pretend that didn't happen because I wrote so messy. chocolate muffins. No, that's good. And it was at point, oh, this is it. I wrote this wrong down. It is 0.0. Okay, here we go. Now we're getting it. Pretend that didn't happen. Important little rule here that you can take away from my mistake is don't write so messy that you can't read it. Work neat. I'm trying to work fast because I know that my batteries are running out on the phone. Don't work fast, work neat. All right, let's try this again. Okay, there's our frog right here. He's about to go hopping. He's hopping from basic to milli. So 1, 2, 3 frog hops. 1, 2, 3 frog hops. The answer is 84.65 milliliters. There you go. I confused you, didn't I? Sorry, I'll do another one. I'll do better. Okay, this one time we're going from millimeters to kilometers. So we're going to go from here that way 6 places. 1, 2, 3, 4, 5, 6. So we're right here. 1, 2, 3, 4, 5, 6. So our answer is 0.745378 kilometers. Okay, now let's try it again. Get rid of that. Okay, this time we're going from milliliters to liters. 1, 2, 3 this way. 1, 2, 3 this way. The answer is 80. And you can keep your significant figures liters. Okay, this time we're going from meters to centimeters. Meters is a basic unit. That's 2 frog hops that way. 1, 2. So we augment zeros if there aren't any. And it's 83500 centimeters. There, got through all that. Okay, so now we are on number 20. We're supposed to put 634 in scientific notation. Remember, this is a pet peeve of mine. I don't like doing this. 634, we can imagine what that is. Once we put it in scientific notation, nah. But 634, well, we're going to change it first. So this one isn't so bad. Kilograms to milligrams. So, King Henry's daughter bakes delicious chocolate muffins. And we're going from kilogram to milligram. 1, 2, 3, 4, 5, 6. My decimal's right here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So it's 6, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? So now I'm going to put it in scientific notation. My decimal's right here. It's got to hop into its proper place right there. 1, 2, 3, 4, 5, 6, 7, 8. So it's 6.34 times 10 to the 8th power. And this would be in milligrams. Ta-da! All right, next. This is vocabulary. I'll just talk over it real quick. A systematic approach used in all scientific study is called the scientific method. How close you get your data points are to an accepted value or reality is accuracy. How close your data points are together is precision, and it also can be how finely stated it is. A base unit is meter, liter, gram, second, etc. A scientific notation is this, where it is written in the shorthand. Dimensional analysis is where you use units to figure out if you did your math right or not. If you get something like grams per milliliter for density, you did it right. If you get the square root of grams, you did it wrong. Conversion factor is where we change units using railroad tracks. It works because you are multiplying things that are mathematically equal to 1, and anything multiplied by 1 is itself mathematically. The reason why it is equal to 1 is because they are equivalent, and anything divided by itself is 1. So it's like 7 days a week. You could change days in a week or weeks into days. A derived unit has math in it, like miles per hour. Per means divide. Density is mass divided by volume. A liter is the base unit of volume. A gram is the base unit of mass. The significant figures means that they were measured, and you have to follow the rules for that. A meter is the base unit of length. A second is the base unit of time. Kelvin is the base unit of temperature in the SI system. Celsius is in metric. And Fahrenheit is in English. Mole is an amount. It's equal to 6.02 times 10 to the 23rd of anything. It's a word like dozen or pair. It's what we use to measure atoms in. You would never get a mole. I've one time heard that a mole of sand would cover the whole earth. So it's a lot. Qualitative shows the quality of something. Is a descriptive observation like green, where quantitative is a number like 6 meters. What is the molar mass of nitrogen? That is the decimal number on the periodic table. And so nitrogen, you can round it off, it's 14, and that's grams per mole. So if I were to go get a mole of nitrogen, I would weigh out 14 grams. What's the molar mass of oxygen? Well, oxygen is diatomic. It hangs out in two. Oxygen, there's 2 of them, and the molar mass rounded off is 16. 16 times 2 is 32 grams per mole. So the molar mass of O2 is 32. And how many grams are 6 moles of gold? So how we do this, let me erase this so I'm ready to look at you. How we do this is first we write what we know. Remember, that's my hand signal to you. And what we know is 6 moles of gold. Okay? We draw our railroad tracks. What goes in the bottom? Moles, because we want them to mark out. It's satisfying. What goes on top? Grams. That's what we want. And now we write the relationship. And 1 mole is 196.97, the molar mass of gold. So you multiply any number on top, you divide any number on bottom, moles cancel out, and you're going to be left with grams. So the answer is 1.82 grams. Now, what about significant figures here? Here we don't use significant figures because this is a measured number, and counting is considered to have infinite significant figures. So if I counted out 3 oranges, then you don't use 3 as your significant figure because you counted it, you didn't measure it. I didn't use a balance. I didn't use a meter stick. I counted. And 6 moles is like 6 dozen. It's counting. So, and this molar mass came from the periodic table. So it's not considered, you don't count its significant figures either. So this has infinite significant figures. We write it all down. All right? Science is great. If you didn't understand something, rewatch it. Rewatch the original notes videos. And I'll see you back in school on Monday. See you soon.